So hydropower, tidal, and geothermal energy. This is the last section of chapter 20. And these are kind of, I don't know if newer is the right word, but maybe starting to take off in some areas. There are some countries that are using one or maybe more of these sources of energy already and are almost entirely reliant on them, which is really exciting. There are some countries where development of these sources are just taking off and getting started. So we've been using falling water for a long time. This is one of our older kind of sources of energy, but it is something that has not kept up with the world's energy demand. So it has a lot of strides to go to grow in its efficiency and its use as well. But countries like Norway use hydropower almost exclusively. So according to this, it says 99% of their electricity. That's a lot of reliance on hydropower. But they also are in a good situation for that because of the numbers of rivers and streams and all of the flowing water that they have access to. Part of the problem with hydroelectricity is that most of it comes from dams, and that can be okay. Countries have a lot of pride in dams. If you have a dam, that can create a big lake and reservoir of water, so people can kayak or boat or fish in that reservoir. But it can be a problem if the country is arid and dry, because that allows for a big body of water for evaporation to occur from. And also it dries up everything further downstream. So it can completely change the habitat downstream if you create a dam. And it can displace people and animals beyond just changing the habitat. So those are some potential issues. The biggest dam in the world is in China. It spans 2 kilometers. It's huge. But the issue, or one of the issues with that, is that the floods that people in China have always relied on to grow fisheries and farms don't happen anymore because the dam's blocking that. So when the rain comes, there's no flooding. The dam prevents that from happening. And that's a problem because it's put farmers out of work, and it's killing the fisheries' ability to work well as well. So if the dams break, then you have a huge issue as well, and that's a problem. A dam's different than a levee. I don't know if you've heard of levees before, but a city like New Orleans has levees. So New Orleans is actually supposed to be underwater, at least partially. So the levees keep the seawater from coming into the city. And when the levees break, then the city gets flooded. And I think that happened during Hurricane Katrina. So it's been a little while, but if a big dam breaks, you can imagine all the flooding that would cause as well, and the potential loss of life, not to mention the fact you've lost your dam, so you're losing all the power that it was generating until you can fix the dam as well. Another side effect of dams is that where there is a lot of vegetation, because the water just sits, that vegetation can rot and just decompose in the water, so it affects the water quality, so it affects any of the fish and other things like that are in the water, and that can be a problem. It can also ruin the dam if there's a lot of vegetation that gets caught in it. And so then some people are asking, how can we use hydropower if dams are a problem, especially large-scale dams? So people are looking at alternatives, so smaller scale things like low-head hydropower, which makes smaller dams. So it's still using some of the technology behind dams, but rather than being so big, they're making them in smaller sections, so there's less damage. It doesn't cost as much. If one of them breaks, then there's not as much to repair. It's not as big of a deal. There are also run-of-the-river flow turbines, which means you literally just stick a turbine in a river. And when the river's running, which it pretty much is all the time, then your turbine's spinning. And that is something that you can submerge and pull out to maintain. You can submerge it and pull it out maybe during the winter so it doesn't freeze. So it's more usable and easier to get to. That wouldn't interfere with fish being able to spawn. How many of you know about a salmon's life cycle? Yeah? Okay, so salmon travel from lakes down to the ocean and back every year. So in order for them to get back upstream, dams are a big issue. So some scientists have built like bridges or ladders for the fish to jump up so that they can get around the dam, and the fish are smart enough to figure that out. But if they don't have that available and the dam is in the way, they can't get back to their spawning grounds, so they wouldn't be able to reproduce. Another smaller scale operation is a microhydro generator, and that runs essentially the same way as run-of-the-river flow, but it's enough to produce electricity for a small house. So you could potentially have a microhydro generator and power your home using just that, if you have enough water pressure. So one of the only issues with small-scale hydropower systems is that it can cause people to abuse the availability of water. So in a place where there are water crises, like in the southeast, where the water table is starting to run low and they're worried they're going to run out of water, using a small-scale hydropower tool would not be helpful, because it's going to cause people to run water more than they need to, or maybe abuse the access to water that they have. So geothermal energy. Geothermal energy is amazing. Pretty much everywhere in the world can take advantage of it, even if they don't have access to as much energy as some of the countries that exclusively use geothermal energy. So looking at page 473, that talks about some countries that are using geothermal energy for heat and electricity almost exclusively. So Iceland's one example, Costa Rica is another example. They're able to do that because of their location to volcanoes and the tectonic plates that they're on. So Indiana, not as easy to get access to the heat that Iceland and Costa Rica have access to. However, how many of you have a basement? Okay, so it's colder in the basement, right? So in the summer on a hot day, you can go in the basement and you can cool off. Yeah? Hopefully you've noticed that. If you haven't noticed that, and if you don't have a basement, next time you go to somebody's house, if they have a basement, walk down into their basement and just notice the temperature difference. That's really what geothermal energy is really useful for, because it provides that temperature difference. So in the summer, when it's hot outside and your house is hot, if it's colder underground, you can pipe that cold air up and cool off the house, so it helps with cooling costs. And you're not using electricity except for a pump to pump the air. So it's much less than using the actual air conditioner system to cool your house. In the winter, the opposite effect is true. Maybe not initially, but once you get about halfway through winter, it will probably actually be warmer underground than the outside air is, so it can help keep your house warm at a base temperature. It's not going to be warm enough to walk around in shorts and a t-shirt in your house, but it's better than not having any heat at all. So it's one way to help balance out the temperature differences. And geothermal energy is again pretty much available anywhere. If you have enough room, then you can do something like what's in this figure and have tubes that lay down in the ground. This looks kind of like a septic system, if you've ever seen one of those. So it takes up a lot of ground space. Not everybody has the ability to put in a system like this, so if this doesn't work, you can dig a hole or a big well and put tubes vertically down inside that well. So it doesn't have to be laid out horizontally. It can be put down vertically as well. Okay. So we talked about hydropower, we talked about geothermal energy. The last energy source are tidal and then wave energy. This is something that people are still trying to figure out how to harness well. But a tidal station works kind of like a dam, so the turbines can flow and spin both ways. So when the tide comes in, the turbines spin one way. When the tide goes out, the turbines spin the other way, and that can generate electricity. One of the issues with that, though, is that means that the stations have to move, and the time of tides does change year-round, so that can cause some variability in how it would have to hook up to the utility grid, because it is not a constant source. Wave energy, same thing. if we could use the energy of waves that pound along the coastline, that would be a great way to harness some natural energy as well. Just trying to figure out how to do that, though, without that affecting wildlife and without that affecting maybe the economic benefits of having coastline and beach is something for scientists to work out. One of the things that you should be familiar with is this OTEC, which stands for Ocean Thermal Electric Conversion. And this is the idea that there's a difference in temperature in different layers of the ocean. So the surface of the ocean is hotter than the bottom of the ocean. And the idea is that if you can use the heat from the upper layer to evaporate a liquid, that'd be something like ammonia or freon, which has a really low boiling point, so it'll evaporate at a low temperature. Then that gas is used to spin a turbine. And then the cold water can be pumped from deep in the ocean to cool off the gas so that it becomes a liquid again, and then it can cycle through that process again. So using the heat at the top of the ocean to turn the liquid to a gas to spin turbines, use the cold water from the depths of the ocean to cool that back down so it can go through that cycle again. Okay, so it's going to loop over and over. That's Ocean Thermal Electric Conversion, OTEC. So the last little bit of the chapter talks about what our future in energy could look like, talking about maybe upgrading the infrastructure that the U.S. has. So how could we tie the geothermal energy that's available in one part of the country to provide electricity to a different part of the country, or the wind power that's available on the Great Plains so that that electricity is available on the coast when it's needed. And that's something that some people are looking at trying to build or talking about building, and what that would look like. So this is an example of that. One of the other considerations is that during the summer we tend to need more energy because people want to keep their houses cool, and that usually takes way more energy than is needed during the winter. So that also varies during time of day. So when we're looking at making a super grid or trying to connect different parts of the country together, you have to take into consideration how people use their energy and when they need it most. So if everybody was trying to run their dishwasher and their washer machine at the same time, that would cause a bigger drain on the power grid. What does that look like? How do you account for people using stuff at different times and not having a consistent requirement or demand on the system? That is something that people with greater minds than mine have to figure out, because I'm glad I don't have to try to do the calculations for that. But these are just a couple of examples of things that we could do. Realistically, we could probably get all of our energy from renewable energy. The question is, do people want to put the time and money into it? So, and yeah, most people are like, no, because it's easier not to. It just, realistically, it is easier not to. So as people decide that that's important, then our country will probably move towards that, but we're not necessarily running in that direction right now. There you go.